All right, guys, so today our lesson is just a continuation of our previous lesson where we were factoring. Today we're going to be solving. So just a recall for you, the zero product property says that if A times B equals 0, then we know that either A equals 0 or B equals 0. So what that tells us is then that when we factor this and the equation is set equal to 0, we can solve and we can find out what x equals and not just factor. So we're taking it just one step further. So questions today are going to look more like this. 3x minus 6 equals x squared minus 10. Our first step that we want to do every time is to get everything moved over to one side so that we can factor just like we did, ignoring the equal sign, and then we can take that extra step to solve. So I always try to keep the x squared positive, so that means I'm going to move everything over to the right hand side. So if I move over the minus 3x, and then I move over plus 6, then I'm left with 0 on the left and x squared minus 3x and then minus 4 on the right hand side. Okay, so we can do our quick check with the discriminant b squared minus 4ac to see if we can solve this. And then we will start to factor it out. So our discriminant tells us this is factorable. So I'm going to ignore the 0 equals and I'm just going to start factoring like we have done. So I want to find something that multiplies to 1 times negative 4 is negative 4 and that adds up to a negative 3. So two numbers that come to mind are negative 4 and positive 1. So I'm just going to bring down the 0 equals, and I have x squared minus 4x plus 1x minus 4. So let's see what we can take out. So 0 equals, I can take out an x out of the first two, so then x minus 4, and then I can't really take anything out of the second two, so just to keep it consistent, I'm going to take out a 1. And I have x minus 4. So then I have 0 equals x plus 1 and x minus 4. Now, here's our extra step. Now that we know that 0 is equal to these two factors, I'm going to set them each separately equal to 0. Then we want to solve each one. So I want to get x by itself, so I subtract 1 from both sides, so I get x equals negative 1. That's my final answer there. I'm going to add 4 on this one, and then I get x equals 4, and that's my final answer here. So often we will get two different answers when we're dealing with quadratics. And if you think about our quadratics and where they cross the x-axis, often they cross at 2 points. That's where those two solutions are. All right, let's try another one. So 9t squared minus 12t equals negative 4. Well, I'm going to move everything over. So I have 9t squared minus 12t plus 4 equals 0. Quick check, do they have anything? Do they have a greatest common factor? So 9, 12, and 4. Can I take anything out of there? No, not really. So 9 and 4 gives me, I want something that will multiply to 36 and add to negative 12. That would be a negative 6 and a negative 6. So then I have 9t squared minus 6t minus another 6t plus 4 equals 0. So then, looking at the first two, what can I take out? And it looks like both of them have a 3t in common. So then I have 3t minus 2. And of the second two, it looks like they both have a 2 in common, but I'm going to go ahead and take that negative out of there. So then I end up with a positive 3t minus 2. So I make those parentheses match, the leftovers match. So then I have 3t minus 2 and 3t minus 2. Okay. Interesting that those are both the same, so we can just set one of them equal to 0. Because if we've solved one, we know the answer to the other. So 3t equals 2 divided by 3, t equals 2/3. So I said often we have two solutions, not always. We're going to think about what this looks like on a graph, and we'll talk about this one in class, where this crosses, why it only has one solution. And if you check the discriminant, what is the discriminant here? All right, find the zeros, the x-intercepts, the roots. So as we solve this one says y equals. That's the only difference. It's telling you find the zeros. We're still going to solve it in the same way. We want to know where 3x squared plus 14x minus 5 is equal to 0. So first we're going to do 3 times negative 5 is negative 15. And then I want to know when it adds to 14. So two numbers that multiply to a negative 15 that adds to a positive 14, I would say are positive 15 and negative 1. So I have 3x squared plus 15x minus 1x minus 5 equals 0. Of those first two, I can take out a 3x, and I have x plus 5 left over. In the second two, I need to pull that negative out, but there's nothing else I can take out. So I'm going to take out a 1, and I have x plus 5 left over. So then I have 3x minus 1, and I have x plus 5. So set them each equal to 0. I'm going to add 1 to both sides on the first one. So I get 3x equals 1 divided by 3. So x is 1/3. If you're able to do this in your head and don't have to write them out, I'm okay with that too on this step. So x equals negative 5. All right, so this is a great one that if you have not gotten down, if you have not printed out the notes, you may want to pause the video and write down all of the important information here before we get going on this. This says, as part of Black History Month in February, an artist is creating a mural on the side of a building. A painting of Dr. Martin Luther King Jr. will occupy the center of the mural and will be surrounded by a border of uniform width, showing other prominent African Americans. The side of the building is 50 feet wide by 30 feet high, and the artist wants to devote 25% of the available space to the border. What should the width of the border be? Okay, as soon as I see something like this, I immediately know I need to draw a picture. So I'm going to draw out this wall where this mural is going to be. So it tells me the wall is 50 feet wide by 30 feet high. There's some kind of border on the wall, and it says it's uniform width. Well, we don't know what that width is, but that means if it's uniform, that it's a distance of x in this direction and also x in this direction, but also here is going to be x. And here is going to be x. So then I also know that 25% of the space is the border. Okay, so if 25% of the space is the border, then that means that 75% of the space is the mural. And I think maybe the mural might be an easier way to start to process the problem. So if I can find what the area of the mural should be, we can find out what that x value is that we're taking away by finding the area, the expressions for the area of the mural. So 50 times 30 we know is 1,500, right? Let's go ahead and write that out. So 50 times 30. That tells me the total area of the wall. So then the mural would be 75% of 1,500, which is 1,125 square feet. Okay, so how does this help us? Well, we know the distance from here to here would be 50, but we need to subtract out this border width. So I need to take away 2x. So the mural will be a length of 50 minus 2x times a height of, same thing here, 30, and then we need to take away 2x. When we've done that calculation, we would get 1,125 square feet. Okay, so it looks factored right now, but it's not set equal to 0. So what we're going to have to do is undo this. We're going to FOIL it all out. We're going to move that 1125 over, and then we're going to factor and find what that x value should be. So if I start to pull all of this out, 50 times 30 gives me 1,500. And then I do 50 times 2x, I get 100x. And then I have 2x times 30, 60x. And then I have 2x times 2x, that's a 4x squared. Since both of those are negative, that becomes positive. That equals 1,125. Right, I'm going to do a couple things in one step. I'm going to move this 1125 over so I can set it equal to 0. I'm going to combine my like terms, and I'm going to put it in the correct order. So I'm putting 4x squared first. Then I have minus 100x minus 60x, so minus 160x. And then I have 1,500 minus 1125, which gives me 375. All right, now, before I do anything else, I want to look, can I take anything out of there? Looks like 4x and 160 both would divide by 2, but the 375 doesn't. I don't think there's anything we can divide out of there. So 4 times 375 ends up being 1,500. So I need two numbers that multiply to 1,500 that add up to a negative 160. Sounds complex because it's big numbers, but if you take a minute to think about it, it's just negative 150 and negative 10. So then I have 4x squared minus 150x minus 10x plus 375 equals 0. I'm going to extend my page a little bit so we can keep this going. So now what can I take out of the first 2. I can take a 2x out. And I end up with 2x minus 75. Of the second one, I can take a 5 out, and I'm going to go ahead and take the minus out. So then I get 2x minus 75 left over. So then I have 2x minus 5 and 2x minus 75. If I solve these, which you can set them each separately equal to 0, we've talked about that several times, I get x equals 2.5 or I get x equals 37.5. Now this is where some of our sense making comes into play. Does it make sense to have a length of 2.5 feet? Does it make sense to have a length of 37.5 feet? And at first glance, I would say, yeah, it does. But if you go back and look at our picture, you'll notice that our wall height is only 30 feet by 50 feet. If x is 37.5, what we've cut out is more than even the initial wall height. So that doesn't make sense to be an answer, even though it is a valid answer when we solve the problem. In the context of the problem, it is not a solution. So our answer here is 2.5 feet. So the border would be 2.5 feet wide all around. All right, let's try one more problem. Okay, this is a maximum minimum problem, and we'll see several of these over the course of this chapter. So in a quadratic, the max and min is the vertex. We should remember that from our first problems that we did. Example 5 says, a shoe store sells about 200 pairs of a new basketball shoe each month when it charges $60 per pair. Each dollar increase in price, about 2 fewer pairs per month are sold. How much per pair should the store charge to maximize monthly revenue? What is the maximum revenue? Okay, so we want to find out the maximum revenue. So we want to know what the revenue is. So revenue is the cost of the shoe times the number of shoes sold. So what we sell the shoes for times the number of shoes sold. So let's think through this. When we sell the shoes for $60, we sell about 200 pairs. When we sell them for $61, we sell 198 pairs. You can calculate and see that max revenue. At this price, we would get $12,000. At this price, though, even we've increased it $1, we've sold less shoes, but we end up with $12,079. So we've earned a little more money. So we want to find where that tipping point is, where the top of that vertex is. So we're going to set up an equation based on the revenue. So the cost of the shoe for every $60 and dollar increase is what we're looking at. So we're going to start at $60 for every dollar we increase. So we want to be able to show every dollar we increase. We know then that we start at 200 with the $60, but for every dollar we increase, we lose 2 pairs. So I'm going to take away 2x. So that if I plug in a 5 in the first blank for x, 5 in the second blank for x would mean that we sold 10 fewer pairs. All right, what I want you to do here is pause the video, and I want to go into your graphing calculator, and I want you to solve this by finding the maximum in your graphing calculator. So you're going to type this into y equals, and you are going to go in on y equals, type in 60 plus 1x, 200 minus 2x, and then you are going to go over to math. No, sorry, you're going to go over to second calc. And then you can go down to maximum and follow the steps that it asks you to follow. We can go through this together in class as well. You should end up with the point 20 and 12,800. Now, that doesn't mean we're selling the shoes for $20. That means our X value is 20. So if you go look, we would sell the shoes then for $80, $20 more than the 60, for a revenue of $12,800. If you wanted to find out how many shoes you would sell, you could plug it into that second piece there. 200 minus 2 times 20 is $40, so is 40. So 200 minus 40, you would only have sold 160 shoes, but you're making more money that way. So businesses do that to try to maximize their profit or their revenue, regardless of how many items they're selling. All right. We'll talk more about finding max and min on your calculator in class. If you have any questions, though, feel free to come in and see me. I'll see you in class.